Nice. All right. Let's see. We left off right around here yesterday. We didn't spend a lot of time talking about the oscillations, the decadal oscillations. But now they're getting into actual sea level rise and what kind of issues we are dealing with. Let me grab real quick my laser pointer. And where we go? Yes. All right. So the issue that we've been talking about is global warming and sea level rise. And the idea here is, even if you're not talking about ice melting, the ice sheets, glaciers diminishing, just the water that we already have in the oceans is going to expand if the temperature rises, which we've seen that the temperature is rising. There's both a natural component to that and a man-made component to that. But the natural or the average temperatures over the entire globe are rising at a pretty consistent level. So that temperature rise is going to cause the water to expand. Even just the water that we have in the oceans right now, if you don't include any of the water that's melting from the ice, and that's going to raise the sea level. We've already talked about how many people live near the sea, how if you just raise the sea level a certain number of feet, there's going to be millions and millions of people in those areas that are affected. And so this is not, there's a lot of arguing to be had in this. It's more on the details and less on the big picture stuff. Big picture, we are warming. The sea level is going to rise because of that. We are going to face problems because of that. So some conclusions. Thermal expansion and melting glacial ice will contribute significantly to the observed sea level rise since 1961. Difference between observed and estimated sea level rise is considerable, suggesting that additional research is needed. So what they're saying is, we estimated it to be a certain amount of sea level rise. What we're seeing is more sea level rise than that. Hello.
Hey, just left your stuff on the door.
Okay, I didn't see her come in. She come in that door? That's amazing. So what we're seeing is we see a larger sea level rise than what was estimated, which means we need to try to figure out where that extra sea level rise is coming from. Rates of thermal expansion and melting sea ice are accelerated. They're showing the Greenland ice sheet contributing sea level rise that has increased about 4 times in the recent decades. We're going backwards. So could cause significant environmental impacts, and in a little bit we're going to go back and talk about Tuvalu, which is their case study example for sea level rise caused by global warming. So could cause significant environmental impacts, may increase coastline erosion. We've talked a lot about coastline erosion. May cause a landward migration of existing estuaries, requiring beach maintenance or abandonment of human structures. And this doesn't just go for estuaries and animals. If you see a sea level rise, you could see a landward migration of people too, which would put all sorts of stresses on local environments and local economies. So already a threat to some small islands in the tropical Pacific Ocean, already a threat in Alaska, where rapid erosion of coastline, melting of permafrost soils, and loss of protective summer sea ice is pretty common going on in Alaska every year. They talk a little bit about wildfires. Wildfires are related to climate in a complex way. Warming may lead to more drought and El Nino events. Both are related to wildfire events. It is more complex because naturally warming something or having a warming in temperature doesn't directly lead to more droughts and more wildfires, but in certain areas it can. Wildfire events will increase due to global warming, both in frequency and intensity. So warming changes ecosystems, which may lead to several things. A risk of regional extinction of species, shifts in the range of plants and animals. Mosquitoes are moving to higher elevations. We talked about that last class, how different parts of the country that generally don't see very many mosquitoes are seeing more and more of them. Northward movement of butterflies in Europe and birds in the UK. Expansion of subalpine forests in the Cascades. Warming in the Florida Keys is bleaching coral reefs, which are very important to the Florida Keys, not the coral reefs. Very important to the Keys and how they develop and keep their land. Seawater increasing in acidity, threatening coral animals and algae. And so there's lots of different things that happen in the ocean as global warming continues. So they do talk about ocean acidification. And basically, the more carbon dioxide we get in the air, the more of that carbon dioxide dissolves into the ocean water, and it creates an acidic environment. The acidity can affect everything from just the animals, the individual specimens themselves, to their entire reproductive cycle. Acidity is not great for little tiny eggs and little baby animals and all sorts of other things. So, fundamentally changing the structure and function of the ocean chemistry by stressing marine organisms. Heat has been transferred to the upper water labels, a fundamental effect on biological process of marine organisms. So you're saying not only are you getting a more acidic ocean, but it's causing that upper layer to be hotter than it normally is, which is changing the way that animals and plants live their lives out in that upper layer. So I feel like we saw this yesterday, but this is CO2 being dissolved into the ocean. And so the more we have in the air, the more we're going to have in the ocean. It's going to create acidic compounds, and it's going to increase the acidity of the ocean. So impacts on ecosystems. This is specifically for North America. Climate change may be accelerating. The warming is expected to be 2 to 4 degrees Celsius or 3.6 to 7.2 degrees Fahrenheit. And this may not sound like a lot. This is a lot. When you add this on top of our normal summer highs, instead of 100 being your average in the summer, you're talking about an average of 103 to 107. That's quite a bit hotter. That's a significant amount hotter. It's not something to just be like, it's just a couple degrees. That's a big deal. Precipitation in some regions is projected to be less frequent but more intense. The temperature of streams and rivers will likely increase. Wildfires will be more frequent. Growing seasons will be lengthened with earlier spring and greater primary productivity. So that's kind of a good thing. If it warms up, we'll be able to grow more stuff for longer periods of time because it'll always be summer. Rainfall and wind speed from the hurricanes and other storms are likely to increase. Many species will migrate towards higher altitudes, and the oceans are warming or becoming more acidic. So adaptations of species to global warming. As the global warming continues, what's going to happen? Plants and animals have shifted their ranges roughly 3.8 miles per decade towards the poles. So as everything gets warmer and warmer, you're going to see plants and animals escaping that increased heat towards the equator and going further and further up towards the poles, where it used to be too cold for them to live, but now it's actually becoming nice and temperate. So spring is arriving earlier, about 2.3 days per decade. Plants are blooming earlier, frogs are breeding earlier, and migrating birds are arriving earlier. So everything's just happening a little bit closer to that wintertime changeover, and it's affecting the way our plants and animals are cycling through different seasons and through different years. Tropical pathogens have moved up in latitude and elevation, affecting species that may not be adapted to them. Extinctions due to warming may have already taken place. This is what they're talking about with the mosquitoes. Along with the mosquitoes going up to higher elevations or latitudes, you're going to see the pathogens, which they mean diseases, come along with them. And so it's not necessarily the itchy mosquito bite that we're worried with about mosquitoes increasing their range. It's more the things that they carry, the diseases that they're going to easily spread. So 12.7, predicting the future climate. What does our recent history tell us about potential consequences of future global warming? Those that cannot remember the past are condemned to repeat it. This was George Santayana in 1905, and we've heard that a lot. That's the classic quote to tell us to pay attention in history class. But it's true. We see a lot of mistakes repeated over and over and over again. And then we all just kind of look at those people and be like, why? Why did you not see this coming? So they're saying the repetitive nature of many natural processes and hazards is indisputable. Whether you want to argue or not on whether human history cycles about, we can definitely see that natural processes do. So we have a medieval warm period relatively recently, 1950 to 1250 AD. The Earth was considerably warmer than normal and can learn some lessons from that event that happened in the warming period. So winners and losers of that medieval warming period. The winners were aided by favorable climates in their area. Western Europe, flourishing culture and activity, population growth. Exploration, Europe to China, the Vikings to Greenland, Polynesians to Hawaii and other Pacific islands. So what they're saying here in Western Europe, they did pretty well during this warming period. It was rather mild there and allowed them to kind of flourish. I assume they're implying the same things for these cultures that explored outward to new lands during that period. The losers would have been hurt by long persistent droughts. North and Central America saw the collapse of sophisticated cultures. They're saying Mono Lake on the eastern side of the Sierra Nevada in California, Chacoyan in today's Chaco Canyon in New Mexico, and then the Mayan civilization in the Yucatan of southern Mexico and Central America. I guess what they're implying is all three of these cultures collapsed around that time because of persistent droughts. I'm not familiar with the first two. I'm pretty familiar with the last one because of our educational system. So yes, I can confirm that the Mayans did suffer greatly because of droughts and a reliance on drought-intolerant food. Worried about a repeat of these persistent droughts, as we should be. If the last time something happened, the people that live where we live now suffered pretty badly because of it, we might want to perk our ears up when people are talking about the next time that a warming period is going to happen. So the Little Ice Age followed the medieval warming period, 1400s to 1700. More difficult for those in Southeast Asia and Western Europe. Southeast Asia, more volatile climate, reduced monsoon rains and droughts. Europe, storms, wet periods, extremes of hot and cold, and climate change kind of made them struggle a little bit there. Greenland and the colonies in North America were mostly abandoned. Cooling temperatures, increased sea ice, and environmental stress restricted trade. Cultures may not have been able to adapt to changing conditions. That's interesting. I wonder. I have a big question mark around this, but I'd be interested to hear some more about it. How much this little ice age kind of maybe encouraged England to abandon the colonies, or if it was more political. This bullet point seems to be suggesting that the sea ice and environmental stresses played a big part in the colonies in North America being abandoned. I wonder how true that is. Could be true. I don't know. So predicting future climate is problematic. Can attempt to apply uniformitarianism to climate, and that's true. That's all science that we're trying to do now, unless you're talking about like cutting edge physics. We want to apply uniformitarianism. We're going to say if it happened in the past, it's probably likely to happen today or in the future. So what can we look at? The problem is we don't have direct temperature data from time period of interest. So I think they showed on the charts the earliest we were recording reliable temperature data was like 1860. And so we definitely don't have it back into the 1700s or before when we had the Little Ice Age. Attempts to reconstruct temperature data from mid-19th century. Emerging from the data is that warming over the past few decades exceeds that in the past 400 years. And so, they're saying here right up front, the data is not super trustworthy. It's not perfect data, but we do what we can to get the data that's available to us. And then they say, as we look at that data, it's showing us that what we're doing now is seeing a greater temperature increase than in the past 400 years, which should be a little bit worrisome. Less confident in the temperature reconstructions from in the medieval warming period. Limited data suggests specific locations may have been as warm or warmer than today. So as warm as or warmer than today, they doubled up there. Data available for most specific locations suggests that today is warmer than the medieval warming period. And we did talk about, I believe it was the medieval warming period on a previous slide yesterday, that sea level rise that they saw in the medieval warming period, which was, I think, like 7 to 10 feet. Quite a bit of sea level rise for that area. Unsolved question is, what is the origin of rapid climate change over decades to about 100 years that we believe has happened during geological time? What is the origin of rapid climate change over decades to about 100 years that we believe has happened during geologic time? That's a weird question, but I think they're asking why exactly are we seeing a more rapid increase in temperature over the last decades to 100 years? So two other important questions: what changes have occurred and what changes could occur in the future? And I think the answer to the first question, what changes have occurred between this and the last warming period, the main answer there is humans. Humans are here now. We're producing pollutants that go into the atmosphere. We're doing things in general, and those things are going to have changes, no matter how they're intended. We know that warming is due in part to increased concentration of greenhouse gases. Reduction of gases is a primary strategy. And so what changes could occur in the future? Maybe we wisen up a little bit and try to stop the things that we're doing right now that are having these effects. So this is a nice little chart here. What changes have occurred? Climate, severity, storms, past, present, future. What changes could occur? So I guess they're just asking that same question with a nice little graph to give you an idea of what's going on here. Strategies for reducing the impact of global warming. 1997, United Nations Framework Convention on Climate Change in Kyoto, Japan. An international agreement to reduce emissions. The United States has not honored its agreement. European Union has become the leader on climate change issues. We can take a second to talk about this for just a minute. Let's see. I think we've got time. This has actually been a big deal. And there are many people, when you talk about today's economy, that talk about how the United States somehow missed the boat on a lot of this. And we're actually facing it right now. There's lots of people in Congress that are fighting really hard to try to figure out the problem that we have, that China produces like most of the world's solar panels. And we would very much like to produce them here in the United States and start to ramp up our solar panel production and sales and usage. But the problem is China's just literally undercutting all of the American solar panel businesses because they've been making them longer, they make them cheaper, for many different reasons, which we're not going to get into. But when you look back at these opportunities, like the 1997 climate change agreement in Japan, the United States has not honored the agreement. Europe has now become the leader on climate change issues. You're seeing Europe do all sorts of things with electric vehicles, with getting rid of coal-fired power plants and moving to more natural, kind of sustainable power production, along with nuclear power production. You're seeing China kind of, in certain parts of China and certain industries, kind of take off in your renewable resources kind of businesses. And the United States has really just kind of resisted. And for the people in the culture, that hasn't necessarily been a big problem yet. But for industry, we're starting to see the effects of that. And I think, 20 years from now, I think you're going to see a larger portion of our industry and our personal use stuff be more sustainable. I think 20 years from now, there's a good percentage of this classroom that will be driving electric cars. There's a good percentage of this classroom that will recycle a lot and do a lot of simple things that are going to help out the environment. And 20 years from now, I think we'll look back and be like, why did we resist so much for so long? We're all doing this now anyways, So why didn't we start doing this 30, 40 years ago with all the rest of the countries? And why are we having so much trouble competing now? I think it's going to be an issue. And so this right here, this bullet point, the United States does not honor the agreement. This does kind of put us in a little pressure. And you can see that we're doing the same thing with the Paris Climate Accord. And there's a couple other things you could point at where we've kind of gone to the international community and been like, we're going to do this thing. And then we didn't do it. And they did, and they have benefited from it, and we haven't. So just something to keep an eye out, think about. Consider this. If temperature increases on the low side, we can adapt. If it's on the high side, then consequences will be more severe. And I guess maybe that's what we're banking on is it'll all work out. It won't be as bad as we think it'll be, and we'll be able to adapt and pull it out. But we're rolling the dice there. So 12.8, strategies for reducing the impact of global warming. One way to estimate is to examine the geologic record for the past. It will take time for the climate to stabilize when emissions are scaled back, which is why they're kind of making the push right now to scale back these emissions before the large effects start to take place, because once they've already started, it's kind of too late. You might be able to walk back a little bit of it, but it's going to take some time. So this is lag times to stabilization. So they're saying even if you make the change now, if right about where we're at, we continue to grow a little bit, but within the next 100 years, we really cut back on CO2, we stop out our peak emissions, and we start to reduce it, and we level out our CO2 emissions. They're still going to rise in certain areas. So we have temperature stabilization is going to come well after we stop producing so much CO2. Same thing with sea level stabilization and CO2 stabilization in the atmosphere. And so, we start doing the right things now. You're not going to see it until some indeterminate time in the future. Not indeterminate, but some future range. And that's really, unfortunately, being an adult, that's all the responsible things. When your bank account's at zero or negative 50 because you got an overdraft charge, and you make the decision from now on, I'm taking care of my money. I'm going to write down what I spend. I'm going to plan out my paychecks. I'm going to make a budget, and I'm going to stick to it. Tomorrow, when you wake up, your bank account's not fixed. It's going to take you several paycheck cycles and a lot of hard work before your bank account actually stabilizes and you feel like you're doing the right thing with your money. It's not going to be instantaneous, and that happens with all sorts of things in life. You got to plan ahead a little bit. Yeah. You can't wait until you see the police officer to slow down. You have to drive slow or drive the speed limit or close to the speed limit most of the time. And then once you see the police officer, you're already going the proper speed. Don't wait until the problem exposes itself before you try to fix it. Fix it first, and then you won't have to worry about it. Strategies for reducing the impact of global warming. Improved engineering of fossil fuel burning power plants. Use those fossil fuels that release less carbon into the atmosphere, such as natural gas. Conserve energy and reduce dependence on fossil fuels. Use more alternative energy sources. Store carbon in the earth system, such as forests, soils, and rocks below the surface of the earth. And just try to find a way to do things better in general. Even just looking at the cars we have today, way more fuel efficient. Even the gas cars, way more fuel efficient than the cars 20, 30 years ago. Coal, oil, natural gas, they're showing you how much carbon is emitted as a percent of total carbon from fossil fuels. So coal is giving us roughly a third of our total carbon emission. Oil, closer to half. And then natural gas is going to be lower, 21%. But this accounts for the vast majority of our carbon emissions between coal, oil, and natural gas. Let's see. Abrupt climate changes. Okay, so what they're warning about here is fast, quick climate changes. Large-scale change in the global climate system that takes place over a few decades or less. And you can imagine it's just a time frame that they're detailing here. If something were to kickstart this and you were to see this change over a very short period of time instead of over, let's say, several centuries, it's just going to exacerbate everything. So the rapid sea level change from changes in glaciers and ice sheets are going to cause more flooding, and that flooding is going to be harder to deal with because it's going to happen much faster. The more you stretch this out and give people a chance to kind of take it seriously, probably the less problems you will have. Appears abrupt climate change is unlikely in the next century. Things happening that quickly kind of have to be spurred by some sort of catalyst. And without that catalyst, it's probably just going to drag out. So like they're saying here, sea level rises and droughts are the most likely things to occur abruptly, but changes in like the Atlantic Ocean circulation and methane levels are unlikely to occur in the next 100 years in an abrupt manner. Need more geological data to understand the past to make predictions about the future. And then they get back to Tuvalu. And finally, we'll finish this PowerPoint. So remember Tuvalu, really tiny island in the Pacific Ocean. Not a lot of land, literally just like a strip of land, a couple houses wide, and not very high above sea level. I think the average was maybe like 7 feet above sea level. So current sea level rise at Tuvalu for a year cannot be recognized. Change is small relative to short-term seasonal effects of changing trade winds and natural climate cycles. However, effects of rising sea level over several decades will become apparent. Increasing erosion will begin to threaten the stability of the islands. And really, that's where it's at. Every time you get a flood, obviously the flood is bad for the humans. You kind of have to rebuild or deal with the flood during that meantime. Every time you have a flood, you're going to have quite a bit of erosion. And for an island like that, while the floods are really bad and can disrupt your life and cause a lot of personal property loss, the erosion is going to be the biggest deal for that island, especially remembering as we kind of explored that island on Google Earth, it was almost like a circular ring. It wasn't quite circular, but it had like a ring shape to it. And a good half of that ring was underwater. Like you could see that there was some sort of structure there. It just wasn't above the sea level. And so that's what that erosion is really, really talking about. Less that your island gets flooded more frequently, and more that the flooding literally knocks your island down into the ocean, and it's no longer going to be above sea level at any point in time. So prediction of future changes is complex and related to the geologic history of the atolls. Recent sea level rises threatening parts of Tuvalu, especially during high tide, reports of water bubbling up through the ground, flooding of low-lying areas, decreasing availability of the little potable water that there is. If you're not familiar with the term, potable water is drinking water. If it's potable, it's safe for you to drink. If it's non-potable, it's probably salted or has not been filtered or cleaned to the level where you can safely drink it. Sea level on February 28, 2006, the maximum sea level was about 3.4 meters or 11 feet on an island where the average elevation is 7 feet. And so essentially at this date, the entire island was underwater. Widespread flooding now occurs once or twice per year, damages plants by bringing salt water into contact with roots, degrade freshwater resources as the water table rises. And you can see that this is one of those I forget the term for it. It's one of those magnifying effects, the effects that makes this worse. And so one of the effects of the flooding is it damages plants by bringing salt water into contact with the roots. When the plants die, you're going to have much more erosion, and you're going to have flooding that happens more and more often. And so you're kind of in this self-fulfilling cycle of flooding and erosion that's probably, unless something drastic changes, probably going to end up making this island very hard to habitate, to live on.
Snowball effect.
Yes, snowball effect. still can't remember the physics term, but let's see. Erosion of the Funafuti Atoll shorelines, most modest due to reef rubble that is cemented together. So they're saying the erosion here is modest, protects from direct waves. Main shore has been building up rather than eroding, which is pretty nice. Atolls are marginal environments for people. Surfaces generally less than 3 meters above sea level, sometimes between 2070 and 2140. The islets will likely be overtopped and not be habitable anymore. Surfaces will first become unstable, increasing vulnerable to wave attack, might be seriously eroded before overstepping occurs. And so basically, if you're looking at this 2070 timeline, people are having children on the island today have a pretty good idea that their children will not live their entire lives on this island. They will probably have to move to a different area before their lives have run their course. It's pretty sad. So let's see. Here's some reef rubble they have washing up on shore. They did kind of say this reef or the part of the island that has the reef is somewhat protected. It's a little bit more resistant to erosion, and it's kind of slowing the process there. So they say up here it's a buffer to erosion. Adaptation to changing conditions may eventually become unfeasible. People will need to migrate to higher places. Some have already left the country. Potential adjustments to sea level rise and erosion include defending the coast with seawalls. We've already talked about seawalls and how, if used correctly, they can do really well, but they do have their downsides, and there's a lot of ways to put in a seawall that doesn't necessarily have the effects that you're looking for. Planting mangrove trees along the coast to buffer islets from wave attack. We've talked about mangrove trees and their natural ability to kind of hold an island together and allow it to build outward into the ocean. Planting salt-resistant crops for human consumption so that the agricultural activities may continue. Improving storage of rainwater to augment freshwater supply, or importing water to allow you to have more drinkable water to use. And then we get into the summary. So wonderful. Done with chapter 12. And hopefully this video recorded.